Good morning, boys and girls, and welcome back to day 2. Mr. Mortar here again, and we are going to talk about composite functions or function compositions. Okay, today is where composite function compositions is where you use one function to make another function, kind of like yesterday, but now it's where we're going to be plugging functions into each other, where the output of one function is the input of another. All right, so you'll see what we mean here in just a few seconds. But let's start with a little bit of review. Again, we mainly use function notation to talk about different functions. So f of x, talking about f down here on A. J of x, talking about j over here. And when I write something like j of 6 or j of 16, what we're telling everybody is we want to plug 16 into the j function. I want to put 16 in where the x is, right? 16 replace the x there, so I want to put 16 in where the x is over here. So this would look like 2 times 16 to the 1/2. Now going back to last unit, you need to remember that to the 1/2 power means square root. So this really means 2 times the square root of 16, and we all know that the square root of 16 is 4, so 2 times 4 is 8. Right? 2 times 4, and I get 8. All right, so there's the first one. Maybe now on your own, I'm going to pause it for a sec. Go and try f of 5. Okay, f of 5 means I want to plug 5 into the f function. So this is 4 times 5 squared. Again, following order of operations, exponent first, so 4 times 25, and 4 times 25 is 100. All right? So that's not a function composition, that's just evaluating a function, but just a quick little review because we're basically going to do the same thing now, although we're going to do it with a function. And here's what I mean. Up above, we just found f of 5, right? We plugged 5 into the x, right? Now we're going to find things like f of g of x. And all this means is I'm going to plug g of x into the x of f. I'm going to plug a whole function into the x of f, just like we plug the 5. Okay? This, with a little open circle, does not mean multiply. This also means f of g of x. That's just another way to write it. And then these are just functions here, but I can also do it with a number. Okay? F of g of 1. And these are the ones we're going to start with right here in a second. Right? We're going to start with those right there. But this really becomes just kind of a two-part problem of what we just did. All right? And here's what we're going to do with this. Okay, so here's what we're looking at. Number 1, h of g of 9. That's how we say it. When we have just a regular notation, going back up here, this is f of x or f of g of x. All right? So the way I would say this is h of g of 9. All right? And if I want to evaluate h of g of 9, what I'm going to do is I'm first just going to go find g of 9. This is no different than what we did above, right? So I got to find my g function, and I want to plug in 9. Well, the g function, again, is x minus 7. So there is my x minus 7, but instead of an x, I'm leaving it blank, because in that blank, I'm going to plug in my 9, right? I'm going to plug in the 9. So g of 9 is 9 minus 7, or g of 9 is 2. All right? Okay, and I'm back. I'm sorry. I had some technical difficulties there that I tried to cut out, so sorry if things are a little bit choppy. But now that we know that g of 9 is 2, I can replace g of 9 up here with that 2. And now we're just going to go find h of 2. Because g of 9 was 2. So I now need to go grab my h function, which is 5x squared minus 3x plus 2. And again, instead of putting the x's, I'm going to put parentheses so I can plug in my 2. So here's our h of x, 5x squared minus 3x plus 2. But again, instead of putting the x, I put parentheses because we're going to plug in the 2 into those parentheses, replacing all our x's with 2's. So now h of 2, or h of g of 9, right, same thing, is 5 times 4, 2 squared is 4, minus 6 plus 2, or h of g of 9 would be 20 minus 6 is 14 plus 2 is 16. So that's how I can evaluate a composite function with numbers. All right, let's do this again now with f of h of 1. Again, if I want to do this, I'm going to start with the inside part, right? Order of operations always start inside parentheses, and I'm just going to go find h of 1. H again is 5x squared minus 3x plus 2, but I want to replace the x's with parentheses, and I'm going to plug a 1 in for the x's. So this just becomes 5 minus 3 plus 2, which is 4. And now that I know what the inside is, now that I know h of 1 is 4, I want to go find f of h of 1, or f of 4. So now I got to go find my f function. And again, watch out here. I don't know if your notes are like mine, but I noticed earlier that our up here, the f is gone. I don't know why. So that should be f of x equals 4x squared. All right, so that's the function I want to grab. So f of 4 would be 4 times parentheses x squared, and we're plugging in the 4 to the inside. So this becomes 4 times 16, or 64. So f of h of 1 equals 64. All right, moving on, number 3 now. All right, so notationally, first thing we're going to say is number 3 looks a little bit weird. It looks different than the ones we just did. So the first thing, I would fix this so that I understood what's going on. When I see G open circle J, again, that really just means G of J. And then now, because that 4 is at the end, this means G of J of 4. Okay, so there's a problem just like the ones we were doing. It just notationally, it looks a little bit different. And you will see both of these notations depending on who's writing the problem, so be aware of that. All right? Now, if we're doing this, again, the first step I'm going to say is you want to go find J of 4. J is x to the 1/2, so parentheses to the 1/2, and I'm going to plug in my 4. And 4 to the 1/2 is the same thing as the square root of 4, which is 2. All right? So now I just need to go find G of 2. So my G function sliding over was x minus 7, right? X minus 7. So this is x minus 7, and we're plugging in 2 for the x. So 2 minus 7 is negative 5. See? Not too bad today. G of J of 4, or G open circle J4, is going to be negative 5. All right? On your own now, what I'd like you to go and do, go try to find J open circle F of negative 2. J of F of negative 2. Hint, first step would be to rewrite it if you have not done so already. Then I would find f of negative 2, do the inside part. And when you do that, you should have got 16. So now I'm going to go find j of 16. And j of 16 is 16 to the 1/2, or the square root of 16, or 4. So j of f of negative 2 equals 4. All right. Hopefully this is seeming nice for you, and with numbers, I don't think it's too bad. It's really just 2 problems in one. Now let's talk about this with functions instead of numbers. At first, I think it always seems a little bit confusing, but once you get used to it again, I don't think it's too bad. Let's take a look at it. So now instead of trying to find g of f of a number, again, we're just going to find g of f, that function, all right? But kind of same idea as above. I want to start with the inside function. I want to start with that. And what I do is, I just, like we replaced above, I replace the f of x with the function it is. F of x is 4x squared. And now we're going to find g of x. G of x, again, is x minus 7, right? But instead of, again, plugging a number in for the x, we are now plugging in a function. We are going to plug in f. We're going to plug in 4x squared. So g of f of x, or g of 4x squared, is 4x squared minus 7. And this is our composite function. All right? Let's try this again with number 6. Now we want to find f of g of x, right? So we said start on the inside and replace g of x with the function it is. G of x is x minus 7. All right? So I want to plug x minus 7 into x. So now I got to go find function f. And f is 4x squared, or 4 parentheses squared. And again, I think especially when you're first starting to set these up, do little steps like this. Just get rid of the x and put parentheses, and then think about, okay, now what do I need to plug in the parentheses? X minus 7 is going to be my input, so I'm going to plug in x minus 7. So, f of g of x is 4 times x minus 7 squared. Now our directions say to simplify, so now I need to multiply this all the way out. So this means 4 times x minus 7 times x minus 7, or if I go and double distribute the binomials in the back, I would get x squared minus 14x minus 49 if we double distribute. And then I just need to multiply everything by 4. And we get f of g of x equals 4x squared minus 56x plus 196. Okay, number 7 conceptually just gets a little bit weird. I want to find f of x. So again, first step, just replace the inside function with the function itself, so f of 4x squared. But now I want to plug this function into itself. F is 4x squared, and I'm going to plug in 4x squared. And then I just need to simplify. If we square 4x squared, we get 16x to the 4th. And then if I multiply that all by 4, I get 64x to the 4th. And that is my composite function. Alright, lastly here again is our weird notation. Again, that open circle, first thing I do just means f of j of x. Right? So I'm going to treat this the same way as the ones before. Plug in my inner function. This is f of x to the 1/2. And now I'm going to write out my f function. And plug x to the 1/2 inside where the x used to be. Power of a power, I'm going to multiply here. 2 times 1/2 is 1. So I end up with 4x. So, f open circle j is the same as f of j of x, which is equal to 4x. Alright, I'm going to let you do the next ones on your own, the next 4 on your own here in a hot second. But first, let's talk about the domain of these 4. Down on the bottom here, we want to state the domain of 5, 6, 7, and 8. So again, we said when you're doing this, you need to think about the domains of the parent functions and the function itself. And the things you're watching out for are square roots and fractions, right? Those are the things that will affect your domain. So on number 5, no square roots, no fractions in either parent function or the one, so the domain would be all real numbers. Number 6, same thing. No square roots, no fractions, so my domain is all real numbers. Number 7, sliding over here a hot second. Number 7 again, f had no square roots or no fractions, so again my domain would be all real numbers. It is number 8 that I got to watch out for, all right? Number 8 in our answer, there are no square roots or no fractions, but j in the beginning, in the setup of this, right, j has a square root, x to the 1/2. So because j is restricted to x is greater than or equal to 0, then so is the composite function, okay? Then my composite function would also be restricted to x is greater than or equal to 0, okay? Any restrictions on the parent functions go to the kid functions as well, all right? On your own, go now try the next 4. All right, so number 9, again, I'm going to plug in x to the 1/2 for j, and I'm going to find h, and h is 5x squared minus 3x plus 2. And I'm going to plug the x to the 1/2 for all those parentheses, and simplify, and I get 5x minus 3x to the 1/2 plus 2. Again, because j has a restriction on the domain, if you had to do domain for this problem, it would be x is greater than or equal to 0. Here is number 10. Again, same idea. Your final answer should be x to the 1/4, or the 4th root of x. And again, because the 4th root of x is a radical, you would also have to restrict your domain to x is greater than or equal to 0. Same with 11. I'm going to plug in f of x, or 4x squared, into j of x, and I get 2x as my answer, and I have to restrict my domain. And then number 12 would be x minus 14.